So, after trigonometry comes circular functions, okay? It uses some of the concepts from right triangle trig to applies here, okay? So the first concept that we are talking about is the unit circle. And today we are going to derive the unit circle. Now, if you had me for pre-calculus, yes. Hopefully you did not forget the unit circle. If you have, then this is going to be a nice review for you. For those who didn't have pre-calculus, you might have encountered the unit circle, but maybe not the whole thing. Or maybe you were wondering, where do these numbers even come from? Okay? We're going to go over that today. So hopefully everyone grab the sheet. Okay? Yes? These notes are filled in. The main thing is I definitely want you to follow along. Okay? Being that they are filled in, I'm not going to spend too much time over explaining unless I have to. So if you guys do have questions, please make sure you ask. But I'm going to see this process. So the unit circle has a center at the origin, 0, 0. So remember, the unit circle is within a coordinate plane. It has a radius of length 1. The terminal side of any angle in standard position will meet the unit circle at a point with coordinates cosine theta, sine theta. Okay? First off, terminal side. Terminal side means the side that creates the angle. Okay? So this side right here that's along your x-axis, this right here is called the initial side. Okay? This is where the angle starts off. Okay? So the other side that creates the angle with the initial side is called your terminal side. This is the one that moves. This is the one that creates the angle. Okay? And when it hits the unit circle, as we talked about in the coordinate axes part of trigonometry, that point can be found by cosine theta and sine theta. You guys remember that from the last unit? As well as tangent is sine over cosine? Okay. In standard position, okay, theta is positive if it goes counterclockwise in the counterclockwise direction, and negative if it opens, it goes in the clockwise direction. Okay, so as you can see here, you have your initial side, you have your terminal side. So if the angle went counterclockwise, it was positive at 135 degrees. However, if it went clockwise, it would be negative. Okay? And of course, you can always find these numbers by taking angles, subtracting 360 or adding 360, because that's how many degrees are in the circle. Being that these are your quadrants, this is quadrant 1, and then this is 2. This one is 3. And then lastly is 4. We know that x is positive and y is positive in the first quadrant, which means that cosine is positive and tangent is positive. Cosine is positive and sine is positive. Since tangent is sine over cosine, two positives when you divide is always going to create a positive, and so on and so forth around the unit circle. Questions on that? Remember, cosine is your x coordinate, sine is your y coordinate. Okay? Triangles look familiar?
Yeah, special right triangles.
Special right triangles, okay? You can use special right triangles to find exact values of sine, cosine, and tangent of 30, 45, and 60 degrees. You guys remember how the labeling was?
Yeah.
Okay, so looking at 30, 60, 90, the side across from the 30 was what? Was 1, or x. You know, not every triangle is going to be, have only 1 here. So if the shortest side is 1, the hypotenuse is what?
2.
Is 2. It's twice as long as the shortest side. The side across from the 60 was what?
1 square root of 3.
1 square root of 3. Okay? And then of course for your 45, 45, 90 triangle, the two congruent sides were both 1 or x, and then the hypotenuse is what? The square root of 2. Okay? These values are used to create your unit circle. Okay? The numbers, the coordinates, where these things are coming from in the unit circle are coming from these two triangles. Okay? So what we're going to do is we're actually going to derive this unit circle. Okay? You got a nice, larger size circle here. If you are using pen, please make sure that you're careful. All right, I don't want to have to give you multiple copies. All right. So in the unit circle, you have degrees. You also have radians, and you also have ordered pairs. We're going to go through. We're going to find everything. say that this point is? It is 0 degrees. Yes, okay? Starting off point. And realize that again, these special right triangles are embedded inside each point in the unit circle, except the ones on your axis, of course. This degree is how far from the x-axis? It is 30. The next one, 45. And this one up here, 60. Bless you. Yes, these numbers just aren't arbitrary. If you wanted to pull out a protractor and measure, this would be at 30 degrees, this one at 45, and this one at 60. The top one, of course, is 90 degrees, okay? Now, before we continue to the rest of the other quadrants, let's go through and let's do the radians next. The radians, those are the ones with pies, okay? No calculator here. There's no need for a decimal approximation. We want exact values here. 0 degrees in radians would be what? 0 radians. So you can say 0 pi, you can say 0 either or, same thing. 30 degrees. It is pi over 6. Remember, there's a conversion that you can use to convert from degrees to radians. Who remembers what that conversion is? It's pi over 180. So if you ever have an issue with remembering what degree goes with what radian, you can always do this. However, you are timed. So, memorizing this is always good. Yes, there's different patterns and tricks and things to memorize the degrees, the radians, and the ordered pairs. But, I don't want to tell you one because somebody might tell you something different. And you just might be confused. Pi over 4 is what? I bet. 45 degrees is pi over 4. What's 60 degrees? Pi over 3. And, of course, 90 is pi over 2. Okay? We are a quarter of the way through a full circle. Now for the ordered pairs. Now realize, each radii that's on this unit circle has a length of what? Has a length of 1. So we already know that this right here, if I use gray, can everybody see that, or do I need to use a different color? You guys are okay? Alright, so we know that this is 1. If I create a right triangle, clearly that's 90 degrees. What's this angle here? 30, which means that this one would be 60. Using what we know about 30, 60, 90 triangles, we already know that if the hypotenuse is 1, the side across from the 30 is going to be what?
I thought the side across from 3.
Well, technically it is 1, and then the hypotenuse will be 2. So if your hypotenuse is given to you as 2, it's going to be half of that. No matter what, the shorter side is always half the hypotenuse, and the hypotenuse is always twice the shorter side. Okay? Lost anybody? So, knowing that the shorter side is 1/2, what's the side across from the 60? 1/2 square root of 3, which can also be written how? Square root of 3 over 2. Using that information, we can actually get our ordered pair, which I'm going to do in a nice little pink color. The ordered pair, it's cosine first, that's your x value, and sine is your y value. What is the x value for 30 degrees? Square root of 3 over 2. It's the x. It's that length there. What's the y? 1/2, and that is the ordered pair for 30 degrees. If you did not have pre-calculus and you guys had algebra 2, you might have. Did you guys do this?
Yes.
You did with the ordered pairs as well?
Yes.
Okay. 45 degrees. If it's 45 degrees, what kind of triangle is created? 45, 45, 90. Maybe not the best color. What's the hypotenuse?
1.
Always. What are going to be the two legs? It's going to be square root 2 over 2. Where does that come from? Okay? Yes. And and we'll spend just a little bit of time on this one. We know that in 45, 90 is 1 and 1 is square root of 2, or x square root of 2. If the hypotenuse is equal to 1, that means x square root of 2 is going to be equal to 1. Divide both sides by the square root of 2. And back from your algebra 2 days, can you have a square root on the bottom?
No.
How do you get rid of it?
Multiply by itself.
What's itself?
Okay, multiply everything by the square root of 2.
The denominator. And when you do that, you'll get the square root of 2 over the square root of 4, which is just 2. And that's where that came from. In case you were wondering. So, what's my order pair?
Root 2.
Questions on that? Last one is the 60. Last one is the 60. It's going to be similar to 30. It's just going to actually be the opposite of 30. Because if this is 60 and this is 30, my hypotenuse is 1. The side across from my 30, which was 1/2, is actually going to be the what? It's going to be the what? It's going to be the cosine. It's going to be the x value. And then the sine value, the y value, is going to be what? Root 3 over 2. So when you write it in, 1/2 square root 3. Questions? Now the ones on the axes themselves, okay, right here is 0 degrees. What is our x coordinate? What's our cosine?
1.
It is 1 because it's the length of the radius. So that x value is 1 and the y value is 0 because we didn't go up any from the x-axis. And over here, 90 degrees, 0, 1. And that's the first quadrant. This pattern duplicates itself across each one of the quadrants. Okay? It duplicates itself across each one of the quadrants. It is symmetrical. So the distance that this point is away from the y-axis is the same distance as this is away from the y-axis.
So it'd be 120.
So this one will be 120 degrees. Okay? This point is the same distance as the 45 is away. So with this angle degree. Same thing here. What's this one? 150. Lastly, half of a circle is how many degrees? 180. And this pattern continues all the way around. If you want to look at it, 30 degrees away from the x-axis, 45 degrees away from the x-axis, 60 degrees away from the x-axis. Or you can base off the y. Either or. It doesn't matter. Okay? What I want you guys to do is I want you to take a few minutes and fill out the rest of the unit circle. Everything copies itself over. Or would you like me to go along with you? So, with the radians, okay? The way I like to treat the radians is, me personally, other people. They might. I like to look at the ones that are the closest to the x-axis. Never mind, say that back. I like to look at it as in 30s, for one, okay? The ones that go by 30, like 30, 60, 90, 120, 150, 180, they go by 30s, yes? I think of it as they go by sixes, okay? 30 degrees was 1/6 pi. 60 degrees is 2/6 pi. Bless you. 2/6, bless you. And bless you. 2/6 reduces down to what? 1/3. 90 degrees is 3/6. 3/6 reduces down to what? 1/2. Okay? 120 degrees would be 4/6. 4/6 reduces down to what? 2/3. So this one is 2 pi over 3. The next 30-degree one. If this was 4/6, this one's going to be 5/6. So 5 pi over 6. And then this last one is going to be pi because it's going to be 6 pi over 6. 6, 6. And that pattern continues all the way around. They match up with your degrees as well. So, I'm going to skip the degrees for right now because I'm pretty sure you guys can figure out the degrees. If this is 6 pi over 6, this next one's going to be?
7 pi.
The next 30-degree one is going to be?
8 pi over 6.
8 pi over 6, which reduces down to what?
4 pi over 3.
4 pi over 3. The next 30-degree one?
3 pi over 2.
3 pi over 2. Because it's originally 9 pi over 6. 10 pi over 6 reduces down to be what?
5 pi over 3.
The next one's going to be?
11 pi over 6.
And then, yes, you do go all the way around a full 360 degrees, which is how many radians?
2 pi.
2 pi. Please do not forget about 2 pi. It is a part of the unit circle. That's what makes it a whole. If you only go to 11 pi over 6, you're not making a full circle. All right? And the ordered pairs literally just transfer over. Okay? Each one of these ordered pairs here, root 3 over 2 and 1/2, they match up with each one that forms a box with it. Okay? So each one of these points is going to have the same set of ordered pairs. The only difference is that in the second quadrant, the x's are negative. In the third quadrant, they're both negative. And then in the fourth quadrant, the y's are negative. But it's the same ordered pair. You just got to watch your signs. And that applies to the 45, 135, this blank one down here, and that blank one down there. And same with 60, 120, and the other two blank ones, okay? So from here, you guys think you can, forgot the fours, huh? Forgot the ones in the middle. They go by fours. Go 45 degrees, you got pi over 4. Another 45 degrees, you got 2 pi over 4. The next one's gonna be?
3 pi over 4.
Another 45 degrees takes you here, 4 pi over 4. The next one? 6 pi over 4 reduces. And then the last one. And lastly, 8 pi over 4, which is just 2 pi. Alright? Radians are usually the hardest ones. And once you get the first quadrant, you pretty much can just copy everything else around. Alright? So if you haven't done so, go ahead and finish off the rest of your unit circle with the remaining degrees and the remaining ordered pairs. All right. Most of you guys are finishing up. Okay. And like I said, you guys are gonna recognize like the more that you work with the unit circle, the more you're gonna see that there's a pattern amongst like your points. Okay, your ordered pairs, pattern amongst your radians. The degrees is a pattern there too, but the degrees is not the issue. A majority of the time, that is not the issue. It's more the ordered pairs and it's also the radians. Okay, so as you guys are learning this and studying this and knowing this like the back of your hand, make sure that you also kind of look for patterns. So then that way, again, I'm not going to ask you to replicate a unit circle on a test. Okay, if anything, that is going to waste time. When you're working out these problems that are going to be within this unit, and you say, for example, you're solving a trig equation, and you get down to the last step that's asking you what is the x value of 60 degrees. Drawing out the whole unit circle is going to waste your time. You're only concerned about 60 degrees. So if you know your patterns or you can recognize different things, where 60 degrees is located, figuring that value out should be a cinch. And that's going to be a lot faster than trying to recreate the whole unit circle when you're only looking for one piece of information, or maybe a total of 4 pieces of information from that unit circle for an entire test. Does that make sense?
You really only got to remember one. I do it like, so 30 degrees, the x coordinate is root 3 over 2. So I, like, from that, you can figure out everything else.
Oh, yeah. That's why I actually spent that time on that first quadrant, because honestly, that's all you need to know. Everything else is just a duplicate or a multiple of it. And here is your unit circle. Okay? All done out. Again, please make sure that you remember this. All right. So So your Thanksgiving homework is drum roll. No homework. No, I'm kidding.
I'm done.
This actually, I think you guys are actually going to like this. Okay, I really, really do. I really, really do. And this is also going to help you guys if you like, even for those who are recreating the circle. If you were like, stalling on different places, this should hopefully help you with the memorizing process. Which why?
Yeah.
Okay? Because I'm supposed to be afraid.
I like that down there.
This bottom one. Yeah, that was interesting. Now, if you. Well, that's not what you. Terrible. Okay? It's an easy A if you put your mind to it. Okay? Plus, when it comes down to end of semester, you won't be asking me for extra credit. Okay? And this is you guys. I don't always care about my grade, but when I do, it's at the end of the semester. And even though I didn't do all the assignments, I ask for extra credit now.
It's too long. You're supposed to be just
No, but this is.
I don't always drink beer. But when I do, I think they'll say
But this one is very short. Okay, put that one there. So what do you have to do? What do you have to do? Make your own. Who is this?
It's Zach from it's also from Saved by the Bell.
Saved by the Bell, yes, Zach Morris. Terrible. Alright, yes, this is a little bit long, but again, this will be on Schoology, and I will also, copy this over. I do not have a hard copy of this. You're going to create an artistic representation unit circle using your choice of medium, okay? So using anything, alright? Now, if you think your medium is not school appropriate or will make Miss Anderson look at you funny,
It's like a tattoo, not.
yeah, I'm gonna look at you funny on that one. But please get prior consent. If you have to question whether Miss Anderson is gonna say something to you about it, how about just don't do it? Alright? Your display should include all the angles in degrees and radians. Please be sure to measure your angles with protractor to ensure the accuracy of your scale representation. If it's something that's like super huge, okay? Honestly, this circle right here that's on your notes, you can kind of also use that as a guide, okay? Am I going to sit there with protractor and measure to make sure that it's 30 degrees? No. However, if your 30 degrees is up here, we're going to have a problem, all right? So, there you go. Also include the sine, cosine, and tangent values of each degree, okay, as well as on your representation. Yes? This is all individual. This is all individual.
Why not? Please.
No.
We can't just two people.
It's Thanksgiving break.
Two people in a group.
It's Thanksgiving break.
Individual. Now, if you guys want to work together, like helping each other with each other's projects, by all means, that's fine. But you guys are turning in different ones. So if someone comes up with an idea, then whoever, you're gonna have to bat that out with amongst yourselves. But I shouldn't have any type of repeating things. Jesus, I hope. Fewer points may be given if your object is already a circle or appears you put very little effort into it. Be creative. Be creative, guys. Have fun.
It's not even a circle.
Listen, you may receive bonus points for going above and beyond. And I do have some examples of ones that I've seen that I thought were pretty interesting. And there's like a simplistic one in there. But here we go. Oh, I didn't score. Accuracy, of course. Neat, organized, legible, labeling. Creativeness, uniqueness, and evidence of effort. Pretty straightforward. Okay. Here's an example. This right here is a toy helicopter, and the propeller blades basically form the circle. And each of the blades have the little labels that have, the information. Okay, this right here shows effort, for sure. Over here, for my science aficionados.
Tell me they
okay.
did not actually sew a quilt.
There you go. You also have a sewn quilt with the unit circle.
Holy
For my
crap.
science people, this one is the unit circle of life. So they got like some sciencey things in there. Okay? Food. Alright, you got pancakes. You got a cake.
you want to make it, but I'm
That shows effort right there.
That
That
shows-
shows effort.
That shows a little-
You drove to the
As
store.
another part of your wallet.
You got a piece of pizza down there, and then a 3D.
Okay, can we stop doing this? 'Cause there's not gonna be any ideas
So
left.
that's my that's my last one. Okay,
We can
we're
use
just some ideas on how you could be, creative, right? Try to think outside the box. Like if you have something that you are passionate about that you like to do, that maybe maybe you're a cross stitcher. Okay, cross stitcher. Anybody know what cross stitching is?
Nope.
Hey, never mind.
What is
If
that?
you pick up cross stitching, you could do something like that. I don't know if you are like really big into like ceramics and or say like your mom or your aunt has like a ceramic wheel. You could make something like that. I don't know. But this is your opportunity to be creative, okay? And let me tell you, I've taught this class for enough years to know that you need to take advantage of this opportunity for you to be creative, okay? Because will this happen again? Probably not. So use this
This is
advantage.
the closest we're gonna get to
Won't
coloring.
get homework.
Yes, this is gonna be the closest you're gonna get to coloring. All right, in this class.
Well,
Are there any questions?
Yeah.
Serious questions for the video?
Oh, well, not for the video, but
What do you mean?
he's asking if
This
it
is
be
for off the
digitized.
record.
Can it be digital? Oh, that's the other one I'm gonna put it. There's actually one that I saw where like they did some crazy like tech type stuff, and it kind of created the human circle, but they used like programming. They did basically like a digital programming thing that created like this design that was the human circle. So you can definitely do something like that, but it better not be something like plain and basic. Like if I'm sitting there and I'm like, that's it. Okay.